Welcome to tonight's video on finding the reference angle of an angle that's larger, that's between 0 and 360, or even spun around the circle a couple times, or negative. A couple things to keep in mind: that the reference angle is always formed by the terminal side and the x-axis. So notice in all these pictures here, the reference angle is between the terminal side and the x-axis. It is never drawn, like for example here, the reference angle is never drawn this way. It is always goes from the terminal side to the x-axis, whether it be here, there, 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 and it forms a right triangle. And the purpose of these reference angles is so that we can find the value of angles that are bigger than 90 degrees. And we can also apply the special right triangles in most cases. All right, so first, we're going to find the reference angle here for 135 degrees. So let's go over some rules first. All right, so to find a reference angle, let's say that the angle's in quadrant 1. All right. Well, so theta is the angle, and that angle is 60 degrees. So let's say here's our reference angle, alpha. All right. Our reference angle and the angle in the first quadrant are the same. So in quadrant 1, the angle is equal to the reference angle. When you get to quadrant 2, however, and I'll draw another picture here. When you get to quadrant 2, so in quadrant 2 here, let's say now it's 120 degrees for theta. And now our reference triangle, remember, between the terminal side and the x-axis. So here's alpha, and alpha here we can get, since this is 180, we can get by subtracting 180 minus the angle. So in this case, it's 180 minus 120, which is 60. So that's in quadrant 2. In quadrant 3, here's your angle. Let's say it's 225 degrees. That's theta. And we'll draw our reference triangle. There's alpha. In quadrant 3, we're going to take the angle, the 225, minus 180, and that would give us 45 degrees. So alpha here is 45 degrees. So in the third quadrant, to find alpha, we go theta minus 180. And last but not least, in quadrant 4 here, so let's say the angle went around to here. So let's say that was 330 degrees. So our reference angle would be here. So what we would do, since this is 360, is we would take, to find theta, we would take 360, to find alpha, sorry, the reference angle, 360 minus theta. So in this case, it'd be 360 minus 330, which equals 30. So that's how you find the reference angles in the different quadrants. So now let's do some examples here. So for example, it says state the measure of the reference angle for each angle theta, and then find the 6 trigonometric functions. So first, theta is 135. So let's draw our picture here. Find alpha. So remember, it's in the second quadrant. So alpha is going to be 180 minus 135, which is equal to 45 degrees. So the reference angle is 45 degrees, which means we have a 45, 45, 90 right triangle, which means the ratios are that the opposite sides are the same, 1 and 1, and the hypotenuse is the square root of 2 times bigger. So that means that the sine of theta, remember in this case, notice sine of theta is always opposite over hypotenuse. Now in this case, if we look at being in the second quadrant, notice the x-axis here is negative, so that's going to be a -1. So when we talk about opposite over hypotenuse in the second quadrant, notice this is also, if we look at this coordinate here, this is also the x coordinate and this is the y coordinate. So sine, and this is the hypotenuse, or we'll call this in another lesson the distance from the origin to this point. So the sine here is 1 over rad 2, which is rationalized to rad 2 over 2. The cosine is adjacent over hypotenuse, or in this case -1 over rad 2, which is negative rad 2 over 2. And then the tangent is opposite over adjacent, so it's 1 over -1, which is just -1. Now you do the cosecant, remember, which is the reciprocal of the sine, so it's going to be rad 2 over 1, which is just rad 2. The secant, which is the reciprocal of the cosine, is going to be negative rad 2. And the cotangent, which is the reciprocal of the tangent, is going to be -1 still. All right. For number 2, notice that this is -120, but our reference angle is still going to be positive, and it's still going to be here. Now what we can do is just, since this is -180, we go 180 minus 120, which is 60, or if it helps you to follow my rules, make this the positive coterminal angle. So if I go 360 plus -120, that means 240 is the positive angle that goes this direction. And then you could go, since it's in the third quadrant, you could go alpha is equal to 240 minus 180, which is 60. Either way, it's going to be 60 degrees for your reference angle. So that means you have a 30, 60, 90 with alpha being 60. So opposite the 60 is always rad 3. This is going to be 1, and this is going to be 2, the hypotenuse. Now remember, since we're in the third quadrant, this is going down, so it's negative and negative, which means when we find our values, the sine of theta here is going to be negative rad 3 over 2. The cosine of theta is going to be -1/2. The tangent of theta, though, opposite over adjacent, so it's going to be rad 3 over 1, negative rad 3 over -1, which is rad 3. So then if we just do the reciprocals, the cosecant, well, that's -2 over rad 3, which rationalizes to -2 rad 3 over 3. The secant is -2, because we just flipped the cosine. And the cotangent, the reciprocal of rad 3, is 1 over rad 3, which rationalizes to rad 3 over 3. All right, so when we're doing this, be paying attention to which values are positive and negative, because we're going to talk about that at the end, and the quadrant does affect that. So in number 3 here, we're in the fourth quadrant, sorry. We're in the fourth quadrant, so remember to find the reference angle here, which is alpha. We would take 360 minus 330, which gives us 30 degrees. So we have a 30, 60, 90. Now this is going to be 1. Actually, it's -1 because it's going down in the fourth quadrant. This is rad 3, because it's opposite the 60, which is here. And this is 2. And so then to find our ratios, the sine of theta, 330, is equal to, in this case, it's -1/2. The cosine theta is equal to rad 3 over 2. And the tangent of theta is equal to -1 over rad 3, which rationalizes to negative rad 3 over 3. The cosecant is the reciprocal, so it's -2 of the sine. The secant is 2 over rad 3, which is 2 rad 3 over 3. And the cotangent is the reciprocal here, so it's just negative rad 3, because it's the reciprocal of the original, not the rationalized version. So why don't you try number 4 on your own, and then I'll flash up the answers after you've finished. All right, so if you notice, it's in the first quadrant. Even though it goes around the circle once, it is coterminal to a 45-degree angle, because if you go 405 minus 360, that it's the same as the 45-degree angle. So that means in the first quadrant, remember, the reference angle and the angle are the same. And since it's coterminal to a 45-degree angle, it would be the same. So that means we're dealing with a 45, 45, 90, which the ratios are 1, 1, rad 2. And then they're all positive because it's in the first quadrant. So then the sine is 1 over rad 2, which is rad 2 over 2. Cosine is rad 2 over 2. Tangent is 1. Cosecant rad 2 over 2. Or sorry, rad 2. Secant rad 2. And cotangent is 1. And you should notice that this angle here has the same values as if you go back to number 1, where it was 135. Notice the reference angle was the same. The only difference is now some of the values are positive or negative depending upon what quadrant it lies on. And notice in quadrant 2, the cosine is negative because of the fact that this value here, the adjacent or the x, is negative. And the tangent is negative because opposite over adjacent, one of them is negative. So notice that was the difference there. Whereas in quadrant 3, notice sine and cosine are negative, but tangent is positive. And in quadrant 1, when we did it the last time, notice they were all positive. And in quadrant 4, notice sine and tangent were negative, but cosine was positive. Which leads us to our last thing, is how do you know which functions are positive or negative depending upon the quadrant? And that depends upon the x and y values. So notice, because notice the adjacent is always the x and the opposite is always the y. And the hypotenuse is always positive. So when taking that into consideration, the first quadrant, all functions are positive. In the second, the sine is positive. The third quadrant, the tangent is positive. And the fourth quadrant, the cosine is positive. So there is a saying, all-star trig class, or I use for my students as well, all students take calculus, hopefully. Anyway, so that means in the first quadrant, the sine is the one in the second, tangent in the third, and cosine in the fourth. And when I do this, I'm only talking about the 3 main ones, not the reciprocal, because if the sine is positive, that means the cosecant is automatically positive. All right, I hope you enjoyed the video, and if you have any questions, please feel free to ask in class. Have a good evening.